we're having gaps in our knowledge base here, in our content. And I know you're frustrated, but you also need to share my frustrations as well. I'm not forcing you to sit there and struggle. I'm trying to get you to own your learning. I chose this question for a reason. It synthesizes all the things that will be on your exam tomorrow, and many of the things that we've done up to this point. So it causes you to think. That's a good thing. So let's try to dissect this step at a time and see that we really do understand. I think that you guys are not used to having to synthesize things, so many of you shut down. And I know that you are all more than capable of solving these kinds of problems. You just have to develop the confidence and the tenacity. Anybody know what tenacity means? Stick-to-itiveness, like you don't give up. So tenacity is an excellent life skill to have. So let's see if we can develop some tenacity and some confidence in our problem-solving abilities. So here is our chart. Poorly written, because my handwriting is not good, but you know that. So we have 4 isotopes. They're measured in AMUs. Can somebody help Sam out and tell him what an AMU is? Atomic mass unit. And what is that? 1/12? Yes, 1/12 of carbon-12. It would be like me saying, I'm going to weigh all of you in terms of Mr. McCabe. And I'm going to make a McCabe scale. And it's 1/100th of Mr. McCabe. So, Mr. McCabe, what do you weigh? 180. So 1/100th of 180 would be what? 1.8 pounds. So I could then say that you weigh, 40 McCabe's, or 20 McCabe's, or 2 McCabe's. I could weigh things. So they picked carbon-12. Anybody have any idea why they would pick carbon-12?
It's an even number without decimals.
More significant than that. What do we know about carbon?
It's in most living things.
Yes, it's everywhere on the planet. It's in living things. And carbon-12 is a very common isotope of carbon. So it turns out that if you make the mass of an AMU 1/12 of a carbon-12 atom, 1 proton weighs 1. 1 neutron weighs 1. So it's a very convenient scale. So we have our isotopes, 4 of them, and we have what they weigh in atomic mass units. And we have this percent abundance. Now many of you jumped right away. The next part of the table says mass number, correct?
Yep.
So do these percents have anything to do with mass number?
No.
No. So be careful. Just because you're thinking, oh, I'm going to multiply this by this, has nothing to do with this. So make sure that you read the tables, especially when you're doing SAT stuff. There are many distractors that people put in your test questions on purpose to try to get you to do the wrong thing. So mass number is a separate question than dealing with this percent abundance. So let's look at, the first question is, what's the mass number? I can't do this without knowing what mass number is. Can someone tell me?
We added protons and neutrons.
All right. Protons plus neutrons. Do you agree?
Yeah.
So normally, the reader would be told some information. For example, you guys mentioned carbon-12. Carbon-12. This is the mass number. So how would I find the number of neutrons if I was told carbon-12? Matt?
Split it in half.
Is it always split in half?
No, because you just added up.
It is. Many times it is split in half, yes, but it's not always. How do I double check? Carbon-12. Where do I go for information? I come over to the periodic table, and what do I see? Carbon is,
6.
what is this 6?
Proton.
Proton. So if I know carbon has 6 protons,